Hello, in this video we finished to prepare our system for CHARMM-GUI and finally started. First of all, it is important to define a group of atoms to which we want to pull our molecule. As an alternative, you can define just one atom as a reference, and it may actually work, but I prefer to define multiple atoms in the midplane of my B-layer. I would have used the whole B layer, but there is a limit on how large your reference index group can be relative to the box size. MD analysis is very convenient to determine all the atoms belonging to the midplane of B layer, as it allows geometrical selections. So I have written a small script to determine indexes of atoms, and I'm going to further append those indexes as an index group to the file with index groups. Make sure that you follow strictly the column widths, as otherwise GROMACS will complain on your modified index file. You can do it any convenient way you want. You can visualize your system and pick those atoms that you are interested in to use as a reference group interactively, and then create this index group or any other way you like. Don't forget to check if your index group is correct by extracting these particular atoms from one frame of your trajectory and visualizing. You further create a TPR file and run minimization. Minimization itself is absolutely trivial, like you do when preparing your system to basic MD. But your system must obviously contain your molecule of interest in bulk water near the membrane, like I have showed you in my previous video. Also, I encourage you to use pre-equilibrated membrane and bulk water prior to ligand insertion for STIRDMD and enhanced sampling techniques based on it. Otherwise, you may get unreliable results. Then I run NVT and NPT equilibration as I would have done it for a protein ligand complex, but in this case I only want to arrange water molecules in an optimal way around my inserted molecule. I expect that you know basics of setting up molecular dynamics with GROMACS, so no in-depth review of NVT and NPT MDP files. MDP file of production run is another story. You need to add a specific block of code compared to your normal MD setup, and in this block of code you define pooling parameters. So you need to state the pool yes to tell GROMACS that you are doing pooled MD. You then need to define number of pool coordinates, and in this case we only have one reactive coordinate, which is the z-axis of our system perpendicular to the membrane xy plane, or system xy plane. And we have two groups. One is our reference group, another is the group of molecule of interest, and we pull our molecule of interest to the reference group. Specifically, we pull center of mass of our molecule to center of mass of our index atoms that we have selected, located in the midplane of our B layer. Two most important params here are pull rate and also spring constant. So pull rate is how often we pull our molecule towards membrane. If this pull rate is too high, you will literally cannonball your molecule and you can rip off your membrane to shreds, blowing up everything. And last but not least, if the distance between your molecule of interest and reference group exceeds half the length of simulation box, the simulation will crash. In this case, you still get your trajectory with your molecule passing through the membrane, but it will only pass once. In most cases, it is enough because you only want to check if this particular parameters of pooling are correct for your ligand and they do not lead to system crash due to membrane ripped to shreds or something like that. And you can further use those extracted coordinates from such trajectory to set up more advanced enhanced sampling techniques like multi-Walker AVH or umbrella sampling, where you literally take like roughly 80 different frames from this trajectory and start a short simulation on each one of them. It really depends on what you prefer and what you need to do next. StirredMD is a good baseline enhanced sampling technique for more advanced stuff. Or sometimes you just use it as an instrument to get some initial state of your system, like insert your molecule into membrane, but not pull it through it, so you can further study something that you are interested in, like kinetics of your drug, how much time it takes for it to leave the membrane, for example, in normal MD. This is a crude method. AVH does a better job by controlling dynamically how much force to apply based on the history of your system. And in the case of basic StirredMD, we have a constant energy that is applied each n steps to push our molecule where we need. Again, this is a bias that you introduced into your otherwise normal system, and you should always use it carefully and think if you even need it for this particular task. You only apply enhanced sampling when some process that you study takes that long, or some event takes that long to occur that normal MD is inefficient. Or if you cannot study at all with normal MD, like if you need to perform some high precision energy calculations of some event or process. It is not limited to just drug permeability studies. You can use pooled MD and enhanced techniques for different stuff. You can, instead of just pulling in some direction, you can, for example, define an angle of rotation and rotate some part of molecular mechanism and do other stuff depending on your needs. And this is how trajectory looks like. In the future, I'm going to cover other enhanced sampling methods, particularly AVH, but I'm not sure how soon.